Okay, so hello everyone, and welcome to our latest webinar. Starting today, Peter Johnson from Arup. Peter is an engineer with more than 45 years of experience at Arup in fire safety, in infrastructure, buildings, and transport infrastructure. So enjoy from one of the founding fathers of fire safety in Australia. And well, Peter will present. If you have any questions, just type them in the chat box, and we'll address them at the end of the presentation. So, all yours, Peter. I will let you share your screen right now.
Okay, I'll share the screen here. Can you see that okay?
Yes, if you go full screen, please.
Yeah. How about that?
Yeah, perfect.
Okay. All right. Well, look, good afternoon, everybody. It's Peter Johnson from Melbourne, and I'm very pleased to be here and make this presentation this afternoon. For those who don't know me, I've been in fire safety for more than 45 years now, I suppose. The first 20 years I worked in a testing and research laboratory in Melbourne. Doesn't exist anymore. It was an Australian government test laboratory. We were heavily involved in fire detection and alarm and other fire protection system testing and certification, as well as some applied research and working on the design of facilities for the Commonwealth government, defence bases, airports, and telephone exchanges, and a whole range of other things. Then the last 26 years, I worked with Arup as a consulting engineer. I spent a year in London in 1996, and then I came back and started the fire engineering practice for Arup. The first probably 10 years was mostly on buildings, including airports, and then the last 15 years was much more involved with tunnels, road tunnels, railways, rail rolling stock, and still some airports as well. So much more on infrastructure. And all through that period, working with governments on building fire safety regulations and working with universities on research projects of various sorts, including in recent years, University of Queensland, where obviously I worked with Jose Terrero when he was there, and then with David Lang and the team there at UQ. This presentation I'm going to give today, and certainly I would love to have questions at the end, so I won't talk for too long, was first given, as you'll see, at the SFPE Performance-Based Design Conference earlier this year, a couple of months ago, and also gave another slightly different version at a webinar for SFPE globally. And so there's some common themes through this, but I've entitled this Design the Missing Link in Performance-Based Design, because as you'll see through this presentation, a lot of so-called performance-based design is really performance-based analysis of a limited number of performance solutions, which really in my thoughts is not really design at all. And we are missing a lot of fire safety engineers who do a lot of modelling and analysis and calculation and write reports, but they actually aren't at the forefront of the design process for buildings and infrastructure. So that's what I'd like to talk about today. A bit of background for those who are not so familiar with the building code and other things in Australia. We've had a building code, a performance-based building code, for at least more than 25 years. So the Building Code of Australia was created as a performance-based building code in 1996 and promulgated through each of the states and territories in 1997. And in that time, we've had a profession of sorts of fire safety engineers because the first courses at Victoria University in fire safety engineering were started, I think, in 1994 or 1995 in anticipation of the performance-based building code coming out. What we need to do with the Building Code of Australia, even to this day, is that the legal requirements are that we must comply with the performance requirements in whatever way we think we can do that. So the performance requirements in the building code, nothing else, they're the legal requirements that we need to meet on any building project in Australia. And they are qualitative. They have lots of words like to the degree necessary, which creates all sorts of problems because we like to be able to measure the levels of safety and say we've got 24 units of safety and that's more than 22 units that the building code requires, and therefore the design is okay. But the performance requirements are written in qualitative terms, and that creates all sorts of problems. In order to meet those performance requirements, the Building Code of Australia allows you to follow the prescriptive deemed to satisfy solutions, or to, in some cases, develop performance solutions as alternatives to the building code. And even that causes confusion because we used to call them alternative solutions, and now we call them performance solutions, although some would suggest that performance-based design should encompass all of the performance requirements, and that is a performance solution. So the terminology trips us up, as we'll see as we go on. A little bit more about the Australian background. Many of our projects are design and build projects. That is, the design gets advanced by a design team, maybe to 30% of the design. And then once that kind of defines roughly what the design is and what the costs are, it's handed over to a construction company who then will finish off the design. They'll do the last 70% of the design perhaps, and then they will build it as well. And often the fire safety strategies or the concept designs that are proposed in the early stage of a project don't get followed through in detailed design and construction. They get changed. But often those concept designs also are suggested by other people, building surveyors, architects, engineers, mechanical engineers. And so often what's left for fire safety engineers to do is simply to do the analysis, the modelling, the calculation, the justification of these limited number of performance solutions or alternative solutions. There may be 6 of them, there may be 8 of them, there may be 10 of them. And some of them are there just because they're a problem for the design or a stuff up in construction. And in many states of Australia, fire safety engineers are not involved after they've finished the analysis of the performance solutions. They go into the fire engineering report, and that's the last that fire safety engineers see. They don't go on site, they don't do inspections, they don't do commissioning. Having said all that, though, there are some brilliant fire safety engineers in Australia doing some brilliant designs and creating great value for the projects. But the question is, could we do better? Could we do much better? And I think the answer to that is yes. We've seen problems in buildings in Australia. Not all buildings by any means, but we've had a series of reports into building defects, often poor quality construction and lack of proper inspections and commissioning, and governments just not interested in auditing and enforcing good standards in buildings. And as a result, ABCB, Australian Building Codes Board, reported a year or two ago that on an annual basis, buildings in Australia have about $2.5 billion worth of defects, and of those, 1.5 billion is in class 2 residential or apartment buildings. And that is a terrible legacy of a whole range of problems that's been in Australia. A lot of the problems have been in waterproofing, but fire safety features in there very strongly as well. And obviously structural issues as well. We've seen building structural failures in Sydney and in Canberra and in other places. and people thrown out of their apartment buildings where they bought, maybe spent $1 million on an apartment, and they've been chucked out in the street by the government because people have said the buildings are unsafe. The government saw all this, but didn't do much about it until the Grenfell fire in the UK, the picture on the left. And suddenly the government got very worried, both governments at the national level and also state level got very worried that, oh, you know, maybe we have a bigger problem than we thought. We'd had the La Crosse building fire where the flames raced up the side in 10 minutes or so. We had the Neo 200 fire, and we had other facade fires, but smaller ones. But La Crosse and Neo 200, the government had seen those back in 2014, but hadn't done anything really about it until Grenfell came along. So the government appointed Professor Peter Shergold and Bronwyn Weir, construction lawyer, to do this report that you see on the right-hand side, the so-called Building Confidence Report, which laid out a very, strong agenda for reform that should happen in Australia. That report accepted it as being very, very good plan for Australia going forward. At the same time, one of the things that helped the Building Confidence Report was that we'd been working on what's called the so-called Warren Centre project from 2017. In fact, we started about a month before Grenfell, so we were ahead of the game in a sense, because a whole range of us, including people from UQ and others, realised that we had a major problem with the profession of fire safety engineering, let alone all the other engineering disciplines that went into buildings. So we initiated this project called Professionalising Fire Safety Engineering and ended up writing 8 major research reports. We felt that fire safety engineers could add a lot more value to the design and construction process, and and as a result, create a better profession for fire safety engineers. So our reports provided a lot of input to the BCR reforms, and our recommendations and their recommendations have a lot of parallels. So we were in the right place at the right time. One of the things we did was we talked about fire safety engineering having a much more holistic and a true design role. So rather than doing the analysis of a few performance solutions, we should look at all the performance requirements, and we should get involved much earlier in design, as happens on really good projects, and lead the design from the beginning, not let other people develop the performance solutions and then we have to do the analysis. In order to do that, we probably need some new competencies for many fire safety engineers. Many fire safety engineers, including a number that work for Arup, sit in front of computers all day and never go out and do site work, never actually get to see what happens in commissioning and so on. Usually because even though we offer that service, we don't get engaged to do it in most states of Australia. And that's a diabolical situation. So we need some new competencies. And we wrote those. David Lang led the writing of those new competencies that fed into Engineers Australia. And we provided a basis for improved professional accreditation and registration of fire safety engineers, which became one of the recommendations of the BCR report. It was all about raising the bar on competency and taking on more responsibility, but through greater professionalism. There's a couple of things on terminology, and this is more for perhaps people outside Australia, but I'll just repeat them again. In Australia, a fire safety engineer is the one who sort of helps select the fire safety measures, evaluates the fire safety measures, and prepares the report, fire safety report, that looks at the performance requirements. Some people call it a fire protection engineer. In other parts of the world, particularly the US, or in the UK, they're typically called a fire engineer only. But the fire safety engineer is that person. The fire systems engineer, sometimes called a fire protection engineer or a system designer, is the person who designs the systems to the generally prescriptive code. So someone who designs a sprinkler system to AS 2118 or a detection system to AS 1670 is called a fire systems engineer, and it's taken a lot to unscramble the confusion in the various state governments who are rewriting regulations, to get them to understand those two roles, that they are different. Occasionally they're done by the one person, but most fire safety engineers are not able to do all the high calculations for hydraulics for a sprinkler system. And equally, people who design detection alarm systems typically out there are not able to do the sort of modelling analysis and leader design that a fire safety engineer can undertake. And we needed to define fire safety strategy. And David Lang and I had lots of discussions about this. The question is the early concept design, all right, I'm going to design a building. I think it's going to have a timber structure. We're going to evacuate everyone simultaneously. We're probably going to have a sprinkler system in there. Is that a fire safety strategy? Well, we are saying now that's not the fire safety strategy. The fire safety strategy is, once we've developed all the measures for fire safety that you need in a building, we've looked at all the performance requirements, we've developed the management and evacuation procedures, we looked at what the maintenance procedures were, and set out how that's all going to function holistically. That's the fire safety strategy. That's the package of measures that needs to then be handed over to those who are going to implement that in construction. That's what we say is the fire safety strategy. That's still an argument to have with people around Australia and around the world, but that's what we're saying is we should be very clear about what the fire safety strategy should be. In the development of it, well, this is, building development 101 in one sense, is that there's a series of steps that we follow through when we're designing a building. We start with what the client requires, what the code would require of us in terms of performance requirements. I'll come and touch on this in a bit more detail. We would feed that into concept design. There may have been a feasibility study done before that. And at that point, a preliminary fire safety strategy often is, fire safety report, beg your pardon, may have been done for the project, which outlines what some of the fire safety measures need to be. That flows through, and as the design team starts to develop design in more detail, a lot of the options fade away. Yes, we're going to build it out of steel with a frame and not with timber. We've explored timber, concrete, and steel for the frame, but in the end, we've come down and we're going to design it using a timber frame. And a lot of the options disappear at that point. It's getting refined, and at that point, we can typically write the fire safety engineering report. And out of that then comes the detailed design. So this is the detailed design of the egress provisions, detailed design of sprinkler systems to AS 2118, detection to 16 to AS 1670, and what is needed for that is all the drawings and specifications that are needed for all those different systems, the passive measures, the detection, the alarm, the hose reels, the hydrants, how the fire brigade is going to access the building and so on. That's the development. And when we get to that point, we're saying that's when we've developed the fire safety strategy. And there on the next stage is really the implementation of that strategy through construction and completion and handover. And often as fire safety engineers, what's happening here? Often as fire safety engineers, why is that doing that? It keeps jumping back. No, it's not going to do it now. Okay. We get involved in looking at what is being provided for the building and what Americans would call submittal reviews, tenders reviews, then into construction, where we should be involved in some inspections and commissioning, but sometimes we're not, often we're not in places in Australia, whereas in many other countries, fire safety engineers are involved in those inspections and commissioning, and then the handover and the development of a fire safety manual. I'm not sure why this is happening. If I'll stop and share and go out and come back in. Let's hope that continues on okay. So just going through each of those requirements in turn, the most important part of any design is to actually read the project brief that comes from the client. I always ask this question at the start of every project that I review as part of Arup or in some joint ventures, whatever. What does the client actually want? And often they want very specific things. Like you see this picture of Chadstone Shopping Centre. They want an open plan sort of look. They want a spectacular roof. They want all sorts of circulation ways. They have a whole range of specific things. They want particular materials used. And often fire safety engineers charge into the design without understanding that. They want to understand the functionality. How is the building meant to work? People move around. What are the fire safety objectives? How important is the insurance requirements? What happens if this was to have a fire and close down for 2 days? At a shopping centre like Chadstone in Melbourne, that would be millions and millions and millions of dollars lost. So it's about understanding from the client what their approach to risk management is. You clearly need to understand the codes and standards, but that's not the place to start in our view. And you need to understand the regulatory and approval pathways. Who's going to approve this thing? Is there a peer reviewer? Need to understand those things, but understanding the functionality of the building. And this is where fire safety engineers do their very best work. I can tell you on this project, we often as fire safety engineers are appointed for a stage like this, which is an example of one of our jobs, before the architect is appointed or the other engineers are appointed, because they realise fire safety is so incredibly important to the development of a project like this. So that's really, really important. Then you get into concept design. Once you've set out some of the very early stages and understand what the client wants, then you can start to get involved. And this is where I think fire safety engineers, with their knowledge and skill, apply their knowledge in the very best way. You know, we're better at it than building surveyors at it. We're better at it than structural engineers. We're better at it than architects who think they know something about fire safety sometimes, but have, you know, maybe 2 or 3 lectures in 5 or 6 years of academic study and think they know a little bit about fire safety. The answer is they don't. And this is where we as fire safety engineers can apply our best knowledge and skills that we've got through our academic training and our experience. It's where we can put in our innovative thinking. You know, we can say to the architects, if you see a picture like this, that roof, let's make it out of timber and not out of steel. The picture at the bottom, you know, rather than have a steel frame, let's look at LVL timber and use CLT for floors. This is where we can be creative and proactive and identify the options, pros and cons. And this is often where fire safety engineers miss out. They don't get involved in the early part of these projects and push themselves forward. We should really apply this holistic design approach right from the beginning. You know, certainly on a qualitative basis to start with, but you need to be confident enough to be at those first meetings and to speak up. And often what we hear from developers like Glenn Lease is the fire safety engineers sat there and didn't say anything. And, you know, they wonder what the value of having a fire safety engineer at the beginning is. We've got to get better at understanding design and what the process is and being proactive from a design point of view. And some of the questions that, you know, we should typically ask at design is the building going to have simultaneous evacuation, or is it going to be phased floor by floor? Or are we going to do defend in place like Grenfell and leave people in the building so they don't evacuate? If it's an 80-storey high-rise building, are people going to evacuate anyway? Are we going to have to design it so that they stay where they are and defend in place? What sort of structure? How big are the fire and smoke compartments? Do we need sprinklers? What are the advantages of having sprinklers? All these sorts of questions that I've got on the screen there are really, really important questions to ask, and they help frame the concept design. And you know, the latest thing, and this is a big issue at the Fire Australia conference recently, is, you know, how many EVs are we going to have in the basement of our building? How many lithium-ion batteries, chargers are we going to have? Is the building going to have a battery bank in it? How many rapid charging stations are we going to have for EV batteries? This is a hugely important issue now in buildings, and just exercising the mind of designers and particularly the fire brigade. So we as fire safety engineers need to know all about EVs, the sort of fires that occur. We need to know everything about lithium-ion batteries. We need to understand everything about how those fires start and what you do about suppressing those. And of course, hydrogen vehicles are coming. Whole new can of worms that we will need to learn about. The picture in the top is of the Macquarie Bank building in Sydney. It's got an external diagrid frame on it, which was all fire engineered at the beginning. And in the initial discussion between the fire safety engineer and the architect and the structural engineer, you know, the whole issue was, could you design a building like that? And how might you show that that external diagrid is going to withstand a fire and not collapse into the street? The fire safety engineer, a guy called John Hewitt in Sydney, was absolutely fundamental to that design. Without him, on day one in that project, that would not have gone ahead in the way that it did. It's a spectacular building with a very innovative frame and fire engineering solution. Just a couple of examples then of projects that I worked on, and certainly in 1996, when I first joined Arup, Arup was involved in the design of Heathrow Airport Terminal 5, and there's a couple of pictures there. It's a very spectacular, fantastic use of steel frame. The big issue though was it going to have one security area or two? The original design had one security area, and I sat at a meeting out at Heathrow and said, well, if you have a fire in this one security area, what's going to happen to that whole terminal building? And they said, oh, well, the whole thing will be shut down. And I said, well, British Airways are going to move all their operations into that one building. And so what you're saying is, if there was a fire in that security area, all British Airways operations nationally and internationally would be shut down. And they all looked at each other and said, well, what should we do? And I said, well, look, you should build at least two, one at either end. So you could operate at least half the airport because you won't have a fire in both security areas. And that's exactly what they did. If you go to Heathrow today, you go to the north end or the south end, and there's two separate security areas. Just came out of that one simple question. And that's my claim to fame on Airport Terminal 5 at Heathrow. Fantastic building. This Fehmarn Belt Tunnel, some of you may have heard me talk about this before. This is a tunnel that goes from Germany on the left to Denmark on the right. And it's an 18-kilometre road and rail tunnel under the Baltic Sea. It'll be the longest road tunnel in the world when it's finished. It's in construction at the moment. And you see the cross-section area. I got an opportunity to get involved with this project on day one. I was sitting in Melbourne and someone from Arup in London rang me and said, that project we put your CV in a while ago, we won that. You need to be in Copenhagen next Tuesday. And so I got on a plane and went to Copenhagen for a week, and we brainstormed the whole design of this project. And one of the contributions I made, I suppose, was they were very concerned that with 18-kilometre tunnel and effectively a rural fire brigade with one fire engine at either end, what was going to happen in the event of fire. And so I said, on the basis of what we did in Australia, they should have at least have a water-based deluge system in it. And that's exactly how that that tunnel came about. We put a deluge system in, and that's in construction at the moment, I think. And so, you know, without that contribution right at the beginning, they might have struggled along and thought, we're going to have to build a fire station in the middle of the tunnel halfway across or something like that. But we were able to provide a different approach that they, certainly at that time, 2009 in Europe, they were very unused to having deluge systems in road tunnels at that time in Europe. Second, Bangkok International Airport. You know, one of the concerns I've got often is fire safety engineers who, the first time they're asked a question, they turn the computer on and start to think they can use a fire model to solve the answer. Well, one of my colleagues, Dave Barber, and I, we went actually to Tokyo to work with a Japanese contractor who was bidding to build the second Bangkok International Airport. And we developed a whole preliminary fire safety strategy. We took no computer with us. We didn't do any calculations apart from those that we could scribble on a page in handwriting. And we were able to develop the whole fire safety strategy for that building because we understood design and we understood what they wanted to achieve with their design, and we understood how airports work. And we were able to put together a fire safety strategy in a week with no calculation, whatever, by understanding how to do design at the front end of a project. Beijing Aquatic Centre, this is a project that Arup was very famous for, is still very famous for. I was not the fire safety engineer on this project, although I had some very, very minor involvement. Dr. Marianne Foley was the fire safety engineer for this project. None of this met the China building code or the building code for Beijing. The travel distance were all different. We had an unprotected steel roof. We used this plastic material, which didn't meet any of their regulations. And the only way this could be designed was by fundamental first principles fire engineering from day one, by understanding functionally how this building was to work, how the structure was to work, and to put together the design through very, very first principles, early design of a building. And the last one, just to repeat Chadston, this is very much a spectacular roof. Again, fully fire engineered. The whole building is completely fire engineered because we were able to start on day one of that project and not get involved towards the end of the project when we couldn't have done anything to change it except address a few performance solutions. I'll move quickly through these things, but certainly during construction, it's vitally important that proper inspections and commissioning are done, particularly for so-called integrated systems such as smoke control, where you might have detection and mechanical fans and doors need to open and the fire brigade needs to be called and a whole range of other things need to be there. We need to demonstrate that the fire safety strategy has been properly implemented. And sadly, this is a really area of terrible problem in Australia at the moment. The New South Wales particularly is getting the idea of this, and they're sending out government inspectors to audit projects, and they are finding, particularly in residential buildings, all sorts of problems left, right and centre in these buildings. I've got a few pictures in a minute. So construction is important, and then completion and handover. And again, New South Wales is now requiring that a building manual be developed with two parts. A part, very simple written English that building owners and occupiers can easily understood, and then the more detailed part that contractors and future designers will be able to use. Because typically on many projects around Australia, after they get the occupancy certificate, the developer and the builders walk away, they hand over a mountain of information, half of which is no one's ever going to use, and the other half is not in the right format, particularly for building owners and occupiers to use. And the classic example of that is one of the buildings in Melbourne was designed with lifts for evacuation. And 3 years after the building was opened, neither the building owners or the building managers or any of the occupants knew that the lifts were there to evacuate people. And everybody avoided using the lifts, even though they were specifically designed for their evacuation. Just a complete failure of handover. So we've got a definition of holistic design, which is that you need to develop a fire safety strategy as per the definition we've got. We need to integrate all those fire safety measures together. We need to properly inspect and commission those and hand over a building manual. And we should address all the performance requirements in the Building Code of Australia. Whatever the mix of performance solutions and DTS solutions, we need to think of that as the holistic design, and that's what fire safety engineers should do, starting right at the beginning of a project in concept design. What are the benefits of that? Well, we think there's some real benefits. It really is a true professional engineering approach. It's what structural engineers do. It's what mechanical engineers do. Mechanical engineers don't start after they're halfway through construction to work out what's going to happen. Neither do structural engineers. They're involved all the way through the project from the beginning. They get involved in inspection, commissioning. As Mary Ann Foley has always told us, we should think design first and the building code second. So work out how the building should function and then fit it into the building code, not the other way around. We need to develop this integrated package which optimizes the functionality and innovation and cost effectiveness. And it's what in New South Wales has now become the mantra. Design it right, get it right first, and then it will, if you do that and you design it right and you get the documentation right, then construction should be right. If you don't do the design properly at the beginning, then there's a huge opportunity to make mistakes in construction. And that's often what happens. If we do it right, then we'll improve the quality of the buildings, there'll be less defects, and ultimately the consumers who live and work in the buildings are going to be the beneficiaries. Are there any concerns with this holistic design approach? Well, our fire safety engineering fees are going to go up, but we're providing a heck of a lot more value. And if we do that and we get it right, then our professional liability is going to go down, not up. Some people think if we get involved in all aspects of design, we're going to impact our professional indemnity insurance. But I think the opposite is true. People who've been in legal cases found negligent is because they haven't looked at all the aspects of fire safety, because they're all interrelated. Egress and detection and suppression and fire brigade intervention, they're all linked together. Is there a resource availability challenge? Sure there is. We need every single one of you guys at UQ to come and work in Australia and be a fire safety engineers. And you need to encourage every single person in engineering to do fire safety engineering. We need more fire safety engineers, and this is a global problem. Companies like Arup want, 10 more fire safety engineers. We need 10 more fire safety engineers in New York today. There's some tremendous opportunities to build a career in fire safety engineering around the world, and we need them in Australia as anywhere else. There's a competency challenge. Fire safety engineering can't be just about the performance of materials and modelling and calculation. You need to be able to talk design. We need more people being able to talk design at the early stages. And we need people who can go on site and do proper commissionings and inspection and know the difference between a diesel fire pump and an electric fire pump, and know what happens about when you look at a fire alarm panel. So there's some challenges in the education program, and we've set that out, and David Lang and I and others have been working on these challenges to do with how we educate fire safety engineers. There's new competencies, and certainly that's a significant issue. Just hold one sec. Sorry, I was just checking on the time. There are some new competencies that we've written, and they're now with Engineers Australia, and we're saying if you want to be registered as a fire safety engineer, then you need to meet these new competencies. If you want to learn anything more about this, then certainly David Lang can tell you all about that. There are also a series of reforms going on in Australia. So we're starting to see governments, both the national level and particularly New South Wales, calling for a holistic design approach. In fact, we've written so much about holistic design approach now that if someone designs a building and they don't use a holistic design approach and something happens to that building, they're going to have to work very, very hard with their lawyers to get themselves out of a situation like that, because we've said it so much and written so much about it and supported through the Warren Centre project, where we had something like 75 people involved. So there's a lot of evidence out there that that's got to be the way forward. We have a national registration framework for fire safety engineers that should be registered. We still haven't got there completely, but in Queensland now, to operate as a fire safety engineer, you have to be registered. In New South Wales, in Victoria, and the other states are starting to come along, but they're a bit further behind. And ultimately, if you're registered as a fire safety engineer in Queensland, through mutual recognition, you should be able to be registered in every other state. And in fact, I'm going through that at the moment. So I'm registered in Queensland and Victoria, and not that I want to work for the next 10 years, but I'm going through the process of getting mutual recognition in New South Wales just to test the system and see how well it works. We need to remove conflicts of interest. You know, we've had this terrible situation in Australia where the building surveyor who certifies the building approval in terms of the building code and said the building complies with the building code is employed on that building by the developer. So they aren't necessarily going to be interested in finding defects and upsetting the developer and the builder, particularly towards the end of a project. Some of them do, obviously, but some of them don't. And we've just seen a list of 10 building surveyors in New South Wales who've been struck off, not able to practice or fined, some of them for 10, 20, 30 defects or 30 sets of problems with buildings where they've been found to have a conflict of interest or simply haven't performed at a proper professional level. We need to see more third-party peer reviews, and we see it on, road tunnels. Every road tunnel or railway tunnel that we're involved in, there'll always be an independent third-party reviewer who looks at our work, and we should be very able and proud to put our work out there and have it peer reviewed by another competent fire safety engineer. If we can't do that, then we probably aren't doing a good enough job. There's also this mandatory inspections and testing is now getting a bit of airing, and hopefully we'll get more of that, and building product safety and a national model for the fire brigades. Some of those are happening, but Australia, because we're 8 states and territories, it's slow to happen. This is the building confidence report. As I syndicated, some of those recommendations, and there are 22 recommendations in that report, are being implemented across Australia, but there's a certain degree of slowness in some of the states dragging their heels in implementing some of those things. Are there defects in buildings? Well, some of these come from New South Wales and some of them come from Victoria. David Chandler, the Office of Building Commissioner in New South Wales, has thousands of these photographs. One example, not necessarily these photographs, but he went to an apartment building. It was about to be given its occupancy certificate. The building surveyor was about to sign off. He sent a team of inspectors in. It was a 7-story building with, I think, 77 apartments in it. When the inspectors went through, they found $15 million worth of defects. Every shower had to be pulled out because of water leaking. There was exposed reinforcing, like you see in the picture on the left-hand side, where the concrete cover over the reinforcing was just completely defective. some of these other cracks in the concrete, like you see in these pictures here. Apartment buildings, no separation between apartment buildings, even though there needs to be 90-90-90 separation typically. So you had gas pipes going through, you've got electrical cables going through, you've got data cables going through between apartments. Waterproofing problems, that picture on the right with the black waterproofing, that's a brand new apartment, never been occupied. And it's got terrible mold in it because of major waterproofing problems. This picture down the bottom with the pink polystyrene is, if you can't fill up any of the holes, you just get a polystyrene gun out and spray polystyrene all over the place. And this is a vertical view of a shaft that's supposed to be at least smoke separated, if not fire separated, from one level to the next. We're looking down the shaft, so we're looking on top of it. Someone said, oh, there's got to be some separation between one floor and the floor below. We'll just put a bit of chipboard in there and we'll just cut some holes in it in order to let cables and pipes go through. It's going to do absolutely nothing. And of course, it's combustible. All that's going to do is help fire spread up the building. You know, there are thousands of pictures like this, and these are the sort of defects that people are getting in class 2 buildings, of residential buildings, that governments are now trying to fix, let alone combustible cladding on the outside of many of these buildings. So in conclusion, there are major reforms happening, but they're slow. Governments are not moving fast enough. Hopefully there won't be another building fire. There won't be a Grenfell fire, or there won't be a La Crosse fire like this in Australia, or a building collapse structurally. We fire safety engineers, we have these special skills that we get through our academic training. We need to utilise those more fully, particularly in early design. We should take this holistic approach, not just look at a few performance solutions, or a few performance solutions that have been developed by other people. And we need to follow those performance requirements all the way through. Where we are getting to is more of a safety case or systems approach, hopefully in the future, that's recommended by people like Shergold Weir and by Dame Judith Hackett in the UK. The national registration framework's there, but the states and territories are still slow to pick that up, although we've got that now in place in at least 4 states, and the others are following about behind. We've got challenges in terms of our resources. We need more people like you to finish your fire safety engineering, get out and work for consulting companies and others, and get involved in design and work for fire brigades and others. You need to get these new competencies. What comes with that is greater professionalism. There will bring greater responsibility for fire safety overall, but we think that's the right approach. And really, in many ways, design is the missing link, as I said. Too many fire safety engineers just looking at performance solutions, doing analysis, not actually getting out at the front end of projects and really driving the design, when we're the people who have those skills, and not at the back end getting involved in testing and commissioning. Fire safety engineering is challenging, but in my experience, tremendously rewarding work. And through this, we hope to build the professional status, raise the bar, and make fire safety engineering even more attractive. It's certainly an international career for those who wish to work internationally, as I've done for all my professional working life, having worked in quite a number of countries around the world. It's a tremendous opportunity to have a professional career and create those more robust engineering designs. But the beneficiary in the end is going to be the community. The people who live and work in these buildings are going to get better buildings, better quality, better safety, and better understand how their buildings work. And with that, I'll finish and be happy to answer any questions. I'll stop sharing.
Thanks very much, Peter. Yes, we have our first question from Martin McLagan. I don't know if you want to read them or if you prefer me to read
No,
them.
you can read them if you like.
So he's asking from Sheffield, what are the competencies and skills and knowledge related to fire safety required by the other professionals, say civil engineers, structural engineers, mechanical engineers? What competencies do you think they need to collaborate better?
I mean, what they need to do is they need to have a basic understanding of what we fire safety engineers can do, so that they know to invite us because of the value we can create. So we don't want to think that we have to teach mechanical engineers or structural engineers so much that they can do our job for us. That would be a huge mistake. But they need to understand enough to be able to engage fire safety engineers. For instance, structural engineers need to understand how timber, concrete, steel behaves under heating, and need to understand that if they're going to design, particularly at the moment, a timber structure building, then they need to know that there are some very special things that they need to understand about fire safety in terms of the performance of timber, whether it self-terminates or not, how the connections might perform, and know that they need to work jointly with a fire safety engineer to solve those design problems. We see sometimes structural engineers talking to building surveyors and think that they can work out the answers without talking to a fire safety engineer or not. They are making a huge mistake. For mechanical engineers who might think they know a lot about smoke control, well, they need to know enough to know that smoke control is a lot more than exhaust fans and exhaust rates and how you hook up fans to fire alarm panels. When we go on site as fire safety engineers, typically on buildings like Chadstone, the project manager will say, you fire safety engineers are the only ones who knows how smoke control systems work. We need you there with the mechanical engineer and the electrical engineer and the fire services or fire system designers, but we need you there as the central person to make all those things work. So all of these engineers and architects need to know a certain amount, but not in any great depth. They need to know where their knowledge starts and where it finishes, and when they need to engage with fire safety engineers. For too long, many of these professions have thought that they know enough. I'll give you another example. We at the University of New South Wales, we had a job. They had 100 buildings with 100 different smoke control systems in them, and their facilities management people had no idea how any of them worked. And they called in mechanical engineers to look and see how they might work. They couldn't figure it out. We as fire safety engineers had to go and show them and get them to understand how all those systems work and write down effectively what the design was based on and how they might effectively test them and maintain them. Now, part of that is that whoever designed the systems in the first place never wrote down well enough how they worked as integrated systems, because, as I said before, smoke control systems, you need to know how the detection system works, what triggers which part of the smoke control system, particularly if it's a zone system. You need to know how to alert the fire brigade and what they're going to find when they get there. You need to know whether you've got to drive open doors or open parts of walls to provide the supply air. All of those things need to come together to make smoke control systems work effectively. And fire safety engineers understand how all those bits come together. We're the only profession that does. So I guess it's a long answer, but those other professions need to have some level of understanding. enough to be able to ask the fire safety engineers to get involved and allow the fire safety engineers to do their work. Any other questions?
Thanks very much. I have a question. I'm just curious. You showed a lot of buildings that didn't satisfy the fire safety standards, like after being built. Most of them required a lot of expenditure to fix the problems. What would happen if I don't know, the standards change, and what's your recommendation on how to tackle those problems? Like once we change the way of thinking fire safety in a project. I don't know.
Yes. No, I understand the question. I think, standards do change. For instance, in aged care buildings, up until fairly recently, low-rise aged care buildings did not have to have sprinklers in Australia. We had a terrible fire in New South Wales, which triggered the need and changed the regulations so that you needed to put sprinklers in those buildings. And they have to be, they don't have to be retrofitted. Most building code changes are not retrospective, but smart building owners will be looking at those requirements all the time and thinking about whether they need to upgrade their buildings or not. And that is in itself is a problem, because if you don't have smart building owners who are following that, those things, then often those upgrade measures don't get done. You might think that an insurance company who's insuring buildings would, at the time of annual premium renewal, would be looking at some of those things, but insurers typically don't bother. They just insure them again the next year, and they don't set out inspectors to make inspections. There's a requirement every year for an annual fire safety statement. But again, that's typically someone goes out and says, well, the building code at the time this building was built, there were 25 fire safety systems in there. There are still 25, therefore it's okay. That is an issue, but it's an issue that really needs to be driven by the requirements of risk managers, of owners and owners and occupiers, asking the question. Certainly for residential buildings, the body corporate or the owners corporation who is managing that building should be asking the question, have the building code changed? Why has it changed? Are there new requirements? Let's at least have a look as to whether those new requirements should be implemented. But building codes are typically not retrospective, and that can potentially be a problem.
Thank you. We have another question from Rainey, asking when should a fire safety engineer undertake site inspections? Say if the inspection is undertaken towards the end of construction, they may not be able to inspect a firewall or a smoke wall that has been properly constructed.
Yes, a really, really, really good question. And my answer to that is the fire safety engineers should be involved in site inspections at every stage of the construction, not just at the end. And that's, again, been a problem that often where fire safety engineers are engaged, they're engaged right at the end. They're asked to look at the building and does it comply with the fire engineering report, and they've got no hope of looking to see whether firewalls and smoke walls are being properly constructed. I'll give you another example. In New South Wales, we were called to a residential building, high-rise, where people who owned these apartments could hear the people in the apartment next door. And so it was an acoustic problem. and we were asked to go in and help, and they took the cornices off the walls, the wall between the apartments, and when they took that off, they could look right through at the top of the brick wall into the apartment next door. There was no, the brick walls did not go up to the slab above. There was a big gap that had been covered up by our corners. Just poor construction, not providing a complete firewall. Fire safety engineers, in my view, need to be involved in inspections at a number of different stages where they can check these firewalls or smoke walls and make sure they are properly constructed. I think we can't rely on the certification from a contractor. They'll always tell you that they've done it correctly. I think we have to say that's something we were not able to see. We understand certification have been supplied. But we cannot rely on that because we were not there at the time when the walls were constructed. We haven't seen it. And if we haven't seen it, then we can't verify that it's in place properly. Either that or we've got to do some destructive testing and go and pull off some cornices and actually do some testing. And that's what good fire safety engineers will say, you know, we think there might be a problem here. We're going to pull off some walls, open some walls up, and we're going to have a look and see whether it's right or not. Yep.
Thank you very much. Another question just came in from Shiran. So thanks for the insightful presentation. What can fire safety engineers do to get involved in designs holistically? On typical projects, the developer has quite a small allocation for fire safety engineering in the overall budget. What can fire safety engineers on an individual level do to show the client the benefit of fire safety engineers getting involved on a project holistically?
Yeah, this is the big challenge. You know, as you say, at an individual level, often there's not much you can do. We just have to, as a profession, we need to do a better job of writing about and articulating and speaking at conferences and going to developer conferences and going to engineering companies and building developers conferences and writing about and showing the benefits by using some of the projects that I tried to illustrate before to get a change and to show the value that we can create. The other thing is we're trying to get the governments, and this we've been hammering New South Wales government initially, to write into their regulations, their building regulations, that a fire safety engineer needs to be engaged from concept design onwards. And if we could get that, that would transform things overnight. And we're working on that at the moment. We've just been involved in writing a big report in New South Wales along those lines. So I think we need the profession to be doing a better job of showing the value, and therefore developers and builders in seeing that value, including getting it right first time, getting the design right first time, or showing what can happen through innovation, maybe through a smart timber frame design or some novel fire smoke control system or functionality of making bigger and smaller fire and smoke compartments that suit the functionality of the building, then we need to be able to demonstrate that value. So there's a role for the profession as a whole, and there's a role for government as well. And once people understand that, then the work flows. I can tell you in healthcare in New South Wales, we've worked on, well, literally 10s and 20s and 30s of hospital and healthcare buildings because we understand functionally how they work. We're able to vary the smoke and fire compartment sizes and deal with issues of smoke control and stair pressurization. And we get called day one of those projects now, every single time. in some cases by the developer and the builder, even before they've appointed an architect, because they know we can provide them with real value. We, as a profession, we've got to do a better job of articulating that and getting that message out. And if we can get governments to support us as well, then so much the better. There's a lot of work for us as a profession to do, because on an individual level, you walk into a project and say, you know, I want to do a holistic design. I'm prepared to start on day one, but you're only giving me a fee of $20,000. You know, it's not going to happen. So there's some work we need to do as a profession to make this all come together.
Thank you, Peter. I skipped one question from Shiroyu. So he is asking if you could explain the difference between performance-based design and recovery-based design, or risk-based design or resilience-based design, and how will recovery-based design or risk-based design or resilience-based design will be considered in real projects at present stage?
Yeah, look, I think this is another real critical issue, if nothing else, in terms of a lot of infrastructure, for example. You know, given climate change, given more frequent and more severe natural hazard events, floods, fires, heat waves and other things, you know, we're not going to be able to stop global warming going to probably 3 or 4 degrees. We talk about 1.5 degrees. That's become a joke now. That's not going to happen. It's going to be more than that, because the governments around the world, and including in Australia, are just not taking this seriously. And we're hoping maybe as a result of an election tomorrow that this does get taken more seriously. But Australia is an absolute laggard in terms of where this is all going. So whatever the world decides over the next few years, we are going to have more severe and more frequent events. So adaptation of buildings and recovery of buildings after design, after major events, is going to be really important in terms of resilience and recovery. So every building, I think, and some people will call it resilience, and others will call it sustainability, and others will use the word recovery. But we need to think about how a building performs in the event of a fire or a flood. But we also need to think about how do we get back into operation and recover that facility, whatever it is. In road tunnels, for instance, we've been thinking about this for quite some time. In road tunnels, one of the requirements, or some of the requirements for road tunnel design, is to develop the structural performance of the tunnel in the event of fire, so that the time to repair and recovery is set as a requirement of the project. For instance, we had the Burnley Tunnel fire some 10 years ago in Australia. We had a water-based deluge system in there. The tunnel was able to be recovered and get back into operation in 4 days. That was thought to be remarkable, because many other big tunnel fires around the world have taken days and months and weeks to recover. That still cost Transurban something like $4 or $5 million in lost revenue, but overall they were very pleased that they were able to recover and have a resilient design that got them back in operation in 4 days. A very similar tunnel in North America, the Santa Clarita Tunnel, had a very similar tunnel, similar fire, and it was out of action for 6 to 9 months, with tremendous implications for the community. We need facilities to be able to recover them and be recovered very quickly. And sadly, we've seen quite a number of cases where we've lost power supplies, we've lost water supplies, sewerage stations, other community infrastructure that have not been thought through well in terms of recovery and resilience. We do need to think of that. It needs to be one of the critical risk management requirements of a project. On major infrastructure, we're starting to see that a bit. On buildings, we are not. I mean, another example was the buildings that line the Brisbane River. After the big floods some years ago, they had all the major power supplies and control equipment in the basement. Their major fire alarm panels and equipment were all in the basement. All those basements filled up with water, and it took a long time to dry out all that equipment, throw a lot of it away, replace cables. So the question would be, in that case, a resilient or recovery-based design would have those above flood level, well above, the 100-year flood level, maybe on the top of the building rather than at the bottom. That design is going to be much more resilient. So it is being considered on some projects, but I think we've got to do a very, very much better job. The performance-based design and recovery-based design or resilient design, they go absolutely, completely hand in hand as part of a broad approach to risk management. It's a good question. It needs a lot more work.
Stavros, he wants to ask a question. So go ahead, Stavros.
Yeah.
Hi, Peter. And let me just start by saying happy birthday.
Yeah, thank you very much indeed. Yeah.
Probably don't remember me, but I'm from the Sydney.
I do.
Ah, you do? Okay, cool. Sorry, I don't have my camera today on. I've joined from my desktop. I'm actually now doing a PhD at UQ for your reference. We can talk about that next time.
Yeah, good. Love to.
Out of curiosity, for the tunnel that you talked about that connects Germany and Denmark, you talked about the deluge system.
Yeah.
Probably not many people here know what the deluge system is. If you could explain that. And also, was it activated manually, so they had 24/7 surveillance, or was based on heat detection? And also, did you provide exhaust for the tunnel as well?
Yeah, so
two-part question. Yeah,
sure. The deluge system first. What we proposed, and I'd have to double check on this, but what we proposed is a zoned deluge system. That is
okay.
An array of pipes with open heads where the water is held back by a valve for each zone, where the zone that is initiated by operators sitting in a control room who are getting information from a heat detection system and also zone CCTV cameras and using that in order to deliver the water into the particular zone where the fire is. That's the typical system in Australia. There are so-called water mist systems, which use a much lesser amount of water, but finer particles. We still think, and that's a debate that's going on around the world, we still think the deluge system, which is delivering about 10 millimeters of water a minute per square meter, is a much more robust system because it uses a heavy amount of water quicker than a water mist system. But there are advocates of water mist, and this project, and I'm not sure whether they've set a final contract yet for the deluge or water mist system, but they're getting a lot of pressure because there's a Danish manufacturer of water mist systems, Vid, who might be wanting to pressure the Danish government into allowing water mist system. So it's a water-based suppression system zoned to deliver water. In terms of ventilation, that's a really interesting question. In many of the Australian tunnels, like Airport Link in Brisbane, there's a duct at the roof which has vents which open in the zone of the fire and exhaust the smoke down these long ducts and out ventilation stacks along the tunnel or either end of the tunnel. They are incredibly complex and therefore less reliable than the alternative, which is to use jet fans.
Jet fans, yeah. That's what I thought.
Every distance along the tunnel.
Yeah.
New South Wales has moved to just jet fans along the tunnel now because they're simple, reliable. If the fire's under one set of jet fans, the other jet fans up and down the tunnel will provide the critical velocity to blow smoke in one direction. What we did for the Danish tunnel is we suggested they use jet fans. That took away the requirement to have a ventilation a stack in the middle of the Baltic Sea, which wasn't a very good idea because it's got a main shipping channel in the middle. It also removed, through our approach to innovation with that, it removed 750 million euros of cost. They liked that innovation. And they were pretty happy when we suggested that they could use jet fans. We work with our mechanical engineers out of London who are ventilation experts, and that saved 750 million euro, and it helped get the tunnel design over the line compared with a bridge design, which was an alternative. And I see a quick question there that Thomas has answered. Does that answer that question?
Yeah.
Yeah, it does. Good. Okay. No, I can tell you a lot more about that project. I spent 18 months either in Copenhagen or London working on that project. It's the best project I ever worked on. And it's the best project because I was able to go there and be there on day one. I was in a room, we were about 50 of us locked up in a hotel room for 5 days, brainstorming the design. The greatest project I ever worked on. We were in a joint venture with engineers from Holland and from Denmark. Great companies to work with, as well as Arup, and best project I ever worked on because we were there from day one and able to influence the design from the very, very beginning. And our two contributions, above other things, were to put a deluge system in and get rid of the island that was going to be built in the middle of the Baltic Sea and the shipping lane to and help them win a design that took off beat up the bridge design, which disappeared as an option.
So you didn't experience any, I guess it was under the water, so you didn't experience any wind effects. So I presume that the deluge system was in the same zone with the jet fan.
Yep.
Yeah. Okay.
Yeah, there are always some minor wind effects, less so in a long tunnel like that, but obviously at the entrances, there's potential wind effects, but there's also the wind effects of vehicles. So, the vehicles going down the tunnel, particularly HGVs and trucks, create a velocity of air themselves as they push air down the tunnel. All of that's got to be taken into account, which is by the mechanical engineers. But that question about where the fire is and which zone to release, and also the deluge system is usually designed, and this was designed for 3 zones to operate, so that if you haven't quite got the right zone, you've got the deluge system operating in the one next door on either side. So that deals with, to some extent, with the fact that the fire will be pushed in one direction by
exactly
the airflow that's actually flowing down the tunnel. So that's a really important part of it. It's a quick question about whether the slides and the recording can be shared, and Thomas has answered that. Yeah, that's fine. This presentation was an SFPE one, and certainly you guys and your SFPE chapter are totally entitled to it. It's fine.
Thanks very much, Peter. Also, can just because I thought the project you were just explaining, the underwater bridge, was so interesting. Can we have you again sometime soon?
Yeah, sure.
To have you speak about that project?
It's a great story. Look, I've got I've got a presentation or two that I can share on that one as well. It is a great story because the Danish government, they went about it the right way, not the way we do it in Australia. You know, in Australia, we tender for a big infrastructure project. I mean, the one in Melbourne at the moment, Northeast Link, or something like Airport Link in Legacy Way in tunnels in Brisbane, is that someone writes a tender specification, and then maybe 3 companies spend a huge amount of money tendering for that, and only one's ever going to win, and the other 2 who might spend 20 or 30 or 40 million is money down the drain. So what the Danish government did was they said, we want to get a tunnel design done, and we're going to get a bridge design done for the same crossing, and we're going to appoint one consortium to do the bridge, one consortium to do the tunnel, and we're going to give each of you 50 million euros to go and do those designs. So we were lucky, we were on the tunnel one, and all of that tendering, all that information is available on a public website, whereas in Australia, it's all very secretive and everyone's subject to probity and confidentiality. The Denmark is, I mean, Denmark is a fantastic country. You know, if the election goes a certain way tomorrow, I think I'll leave and go and live in Denmark, but that's just my own political persuasion. But that it's a fantastic country in all sorts of ways, and brilliant engineers, and a fantastic, you know, commitment to social justice and a whole range of other things. And I love it as a country. But yeah, so they gave 50 million to each side, and then there was a competition, and a very public competition. And the people who were designing this one little story, the people who were designing the bridge, they built a model of their bridge and put it in the Copenhagen railway station and said, this is what's going to win the award, or this is the way the crossing is going to be done. And I didn't do it, but I was tempted to put a sign up and said, rubbish, that's nonsense, the tunnel is going to win. And we did win. And the whole design team had a great, huge party with heaps of champagne. And sadly, I was back in Australia and I didn't get to attend the party. But anyway, one day when the tunnel finally opens, I'm going to go and visit it. I'll probably be in a wheelchair by then. So I tell everyone they'll have to get a wheelchair and send me down the portal and into the tunnel on a wheelchair. But hopefully I'll get there. So yeah, it's a good story. It's a great story of fire safety engineering and innovation and tunnel development, and I'll be happy to tell you that story.
Excellent. We'll be in touch then soon.
Okay.
All right. Thanks very much, Peter, for sharing your experience and your knowledge, and for having the patience to answer all the questions, even
that's
on
fine.
your birthday.
That's all right. And certainly if you know, if anyone wants to talk to me at all, you know, I'm happy for you to share my email address. So peter.johnson@arup.com. It's pretty straightforward, but if you want to put that in the chat, and anyone who wants to talk to me about anything about careers in fire safety engineering, not just in Arup, but in any company, you know, people often ask me, you know, I'm not going to come to Arup, but I'm thinking about 2 or 3 of these different companies. What do you think about them? I'm happy to give you advice like that, or if you want to work around the world, you know, where that might be. So yeah, just feel free to give me a call, and I'd be happy to, you know, bring you back and have a chat.
Excellent. Thanks very much, and thanks everyone for joining.
Yeah, thank you.
Keeping everyone posted on our next webinars. And thanks again, Peter, for sharing your time.
You're most welcome. Happy to do it. All right. See you then. Bye. Bye.
Bye.